Welcome to the session. Greeting of the day. In today's class, we will see about the various control systems available for helpful for mechatronics arrangements. In previous classes, we have seen regarding this PID controller systems or process controllers. In continuous with that, the digital processing systems also we should see. Digital signal processings. We know these process controllers are going to convert these analog signals into digital format, and the digital signals will do in the computerized format to do the programs, to update the data, to manipulate the data, and from the feedback systems it has to amplify, enhance the data which is fed back to the system for the actuation. This cycle, the closed loop cycles we know. In accordance with that, the digital signal processing to be done before going for the programming and after coming out of the programs. That one by one we will see. You see, the digital signal processings. The term digital signal processing are discrete time signal processings. How fast it converts the data. Is used for processing the applied to a signal by a microprocessor. Before microprocessor is a programming device, it's a controlling device. But we have to give a proper input to the microprocessor. Not the analog input, not the low voltages input. We have to give the proper input what this microprocessor is going to receive. That is nothing but a digital signals. It means we are receiving the analog. Here it should be converted to the digital form. That is the signal conditioning is doing. And then this digital signals to be amplified or linearized and then to be fed to the microprocessor. The digital signals are a discrete time signals in that they are not continuous functions with respect to time, but exist at only a discrete time, a few conversion over. It's converted to digital, then the microprocessor is going to do the job. Whereas this is about the digital signals. Whereas what about the analog? Whereas the signal conditioning of analog signals requires a components such as amplifiers, such as filters to convert into this signal conditioning process. Here we may receive the input in the analog format, the temperature to be converted to the electrical format of voltage and currents, frequencies. We have to convert this. So you see, what happens there? Voltage and frequency. But now the analog has been converted to digital form. How this is converted? We are using some of the amplifiers, some filters, and then we are converting this analog to digital format. Now, this digital format is in 10 volt. This microprocessor will receive in volts the output. So what we have to do here, we have the digital signal processing. This analog signal processing, this is digital signal processing. Therefore, you see, whereas the signal conditioning of the analog signals, from analog signals, we need the components of amplifiers, we need of filters to convert from analog to voltage, current, frequencies into the digital format. But it may be digital in the 10 volts, in microvolts. That to be converted to the processor, to the microprocessor. So what happens? Here our DSP is there. Here we we are doing. Therefore, it does not need such hardwares, but it need a software programmings to convert the system conditions to be ready to make into the signals which is received by the microprocessor. Digital signal conditioning can be carried out by programs applied. How this is program applied? If it is 10 volt, convert, multiply into the volt. This program it is going to do. What is the input receiving the digital format? It can be digitally converted. Some calculation, some program can be done in the software. So when we need a digital, it become digital. Then obviously, what is a microprocessor? Is already programmed, predetermined programs are there. It receives only 10 volt. But the received input converted analog is in microvolt. Then multiply. So accordingly, we can able to do the programs. There we no need of hardware. Applied program to microprocessor. That is, what is the signal processing? That is nothing but a signal processing. Signal processing. Digital signal processing. Digital signal processing. To change the characteristics of digital filters, all that necessary is to change the software. All that we have to do is nothing but change the software. Change the program, change the software. Immediately, this digital signal processing will be carried out. The program of instructions given to the microprocessor can able to change. Whereas for hardware, what to do? Whereas to change the characteristics of filters used in the analog signals, what we have to do? It is necessary to change the components itself. Change the hardware component itself. We should change it. One hardware will convert only this temperatures. One hardware will convert only this pressures. So we have to change the hardware. But it is not like that here in the DSP. It's only the program and the software we are going to do. A few examples we should go. With the digital signal processing systems, there is an input of the word responses of size of pulse of an output from the another word. The output pulses of a particular instant is computed by a system as a result of processing the present inputs such as pulses together with the previous pulses inputs and possibly the previous system outputs also. We are receiving, this image shows you, we are receiving an analog signal of recording the sound. And here I have an analog to digital converter, ADC, and then from there, now it is digital. But this is maybe in the 10 volt. So from here, DSP is there. This DSP is again digital format, it is a binary format is converting from the digital multiplications are done. From the DSP, it is going to the processor where it contains the memory, where it contains the program, where it contains the processing programs. The feedback, the inputs, output is going to be manipulated there. Now it is manipulated, the received signal is maybe low or received signal is error detected for feedback signal, measurement done. From the measurement it has giving there. It is going in this direction and from the program it is giving back. In which format it gives? It gives in the digital format. From the digital format, this DSP, again digital signal processing, converts, because here it is in 10 microvolts, it is in 10 volts. So it is again digital signal processing done, and this amplified signals are again reduced. Then we have digital to analog converter. Both recording systems and speakers are analogs, the sounds we are hearing. But inside happening is nothing but a digital. So what happens there? It is converted. Again the signals are given back to the playback systems. So recorded and it is playing. This is analog. In between we have analog to digital converters, digital to analog converters. After that we have DSP, digital signal processing. Only digital signals processing. Analog processing is here. Converter is here. This is digital signal. From digital to digital it is converting, multiplication, dividing, those things it does which is required by the microprocessor. So that is. Digital signal processing takes the real world signals like voice, audio, video, temperatures, pressures, positions that have been digitalized and then mathematically manipulated them. Yes, the DSP is designed for performing a mathematical function like, that is what we have done, like add, subtract, multiply, divide, etc. And so these processes are done very quickly. So many calculations are done. That is what in the image also we have seen such an animation. The signals need to be processed so that the information that they contain can be displayed, analyzed and converted to the another type. So one form to another form we are converting and doing such things. So usually it will be in the zeros and ones. Usually it will be in the zeros and ones, and then again from digital to analog and analog to digital it had to be done. The DSP contains these key components. What are they? It contains a memory. Where is it, this memory? You see, we have the memory here, and then we have a data memory, the program memory, the computer engine, CPU, processors, input-output devices. Input-output devices we have. So this is input we are taking here. Here the output. In between the program memory, data memories are there, the processing converters takes place. Right. You see, the converters such as an analog to digital converter, analog to digital converter, then takes the real world signals and turn it into a digital formats of zeros and ones. Now it is digitalized. From there, the DSP takes over by capturing the digitalized information, microvolts to the volts to be converted there. Signal information, processing it mathematically, multiplication, what we have to do. And then later, it then feeds the digitalized information back for the use. In the real world, audio taken, recording done, signal converted, recorded, memorized, and it is feeding back as a signal which can be as an audio. Recording and audio we are hearing. So that the signal transaction takes place there. In the real world, it does this in one of two ways, either in a digitally or in an analog. Maybe digitally it can be able to receive the information. Then there is no use of a analog to digital converter. If you are receiving the information here directly, this part not required. If directly input is in digital format, digital temperatures, such as some other digital signals are received. In the CNC machines we receive digital signals. Those things we can directly convert, if it is so. Otherwise we have a ADC before the DSP as one of the controlling parameters, controlling systems. To illustrate this concept, a diagram below shows the DSP is used in the MP3 audio player. This is what that shown diagram in the previous slide. During the recording phase, analog audio is input through the receiver, recorded device through it is received first, and then this analog signal is then converted to the digital signal by analog to digital format. This is nothing but a analog to digital converter, ADC. We have seen that. And pass it to the DSP. The DSP performs the MP3 encoding process and saves the file to the memory. Yes, that is what we have seen. That is what we have seen here. This is saves to the memories. And then what happens? During the playback, after from memory we should play down audio, receiving. During playback phases, the file is taken from the memory. First it is encoded. Now it is decoding back. by the DSP and then converted back to the analog signals. Here what will happen? It is having the digital to analog converter. Here we have used ADC. Here we are using DSC. In between coding and encodings are done by the DSPs digitally. Coding and encoding mathematicals through the digital analog converters. So it can be output through the speaker. Finally we are getting the output. Input through the recorder, output through the speaker. In a more complex example, the DSP would be perform other functions such as volume controls, equalizations. So we are having in phone equalizing, volume control, brightness, reduction, this and that we are doing. So that's all. Digital signal processing can be done with the help of analog to digital converter, with the help of digital to analog converters, and this coding and decoding with respect to binary digits are done. So various components stores the program in the DSP will use it to process the data, to store the information to the process such as data memories are storing, and it is processing programs. Computer performs the mathematical processings, accessings. This multiplication, addition, subtraction, divisions are done. Input output for receiving the input and giving the output recorder and the speaker audio. Serves as a range of functions to connect to the outside world. So that is how we can able to perform. So this is what a simple finalized image, a microphone we are using, and then it is analog to digital converter, then digital zeros and ones, and then here again the digital to here the zeros and ones computers and the microprocessor, digital signal processor with microprocessor programming done. From here again, this is the digital format, binary digits. So here again we have DSC. This analog converted to the speaker output audio. So that is how we can able to change this of digital signal processing. Data flow in DSP. Even though we know the introductory part of DSP, few block diagrams are there, the same content, how it is formed. These systems can be expressed as a network of transfer functions. Yes, we are doing a transfer functions. Each block represents a function as a addition, subtraction, etc. We have seen. The blocks are connected by the arrow called as a directed X. Through this arc direction, the data moves between the blocks. ADC to DAC, the data is moving. DAC to speaker, data is moving. A recorder to ADC, data is moving. So likewise, through this arc direction, the data moves between the blocks. Such diagrams are called as a data flow diagram. We have here. We have the diagram we have to see. It gives a convenient way to describing what happening. Generally, one understanding you will get in the block diagram. Up to now we have seen the wired connections, some electrical part or electronic part of connections we have seen, how it, the principle, how it happens. But it should be represented in simple block format, then we understand easily. Therefore, it can be easily described through this block diagrams, and it can be easily documented. The connections which are showing through, the documentation can be easily, so for understanding purpose, it looks better when we are going through a block diagram image rather than of the wire diagrams. And the sizing of the signal can be understood. You see here, we have the connections. See here, we have the connections from where these different block diagrams are represented. Here the unit emulsion units takes place. First it started there, from here. Then we have, which is interconnected to both to the sequencer, dispatcher and the program control unit, which contains the CPU, and then this microprocessor controls are there. where it is distributed, we have to distribute to the memory functions, data memory, the buses to be connected to the memory functions. From there, the data memory and the programming memory to be there. It is to be stored, data to be stored memory. And then the programming to be done. At the time, it should be fed back for manipulation. So, memory subsystems are data memory, and then we have a program memory also. So, this is to be fed back here. It is interrelated content. The microprocessor is going to do the job. It is to be going to program, feed, measure, and manipulate and send to the out world. Here, you see, and then where it is connected to the registered file, to data address, communicate the arithmetic calculations, plus and minus divisions, all arithmetic calculations are done there. Interrelated. The functioning is computer is here. The various functions to take place. How many loads, how many stored and registered temporary files to be stored there and executed. Those things are done there, the arithmetic calculations there. What are the other things can be done? Computation and bit manipulation to be done. So, mission MACs are connected here. So, various shift units, how many are there? So, here also we have some temporary file registrations. Mission control management to be done here finally. So, this is a feedback system which it receives, and we can connecting to the microprocessor in such a way the digital signals are split into memories, split into arithmetics, split into the machine controls. And then finally we are receiving everything, manipulation done and given. Evaluations unit for display purposes or controlling units. So that is how this DSP's block diagram, data flow in DSP and layout, and the layout how this is interconnected. This is one part. The remaining part of the subjects, we'll see you in the next session. Thank you.